this one mode of the brain, the default mode, is what you see when people are not engaged with the external world and when they are engaged with the internal world. And this default mode network seems to be disrupted in interesting ways by psychedelics like psilocybin.
Yes, but I will say that it's not just the default mode network. Basically, like all networks are disrupted by psilocybin. And then going back to the claustrum, we found that the connectivity, the functional connectivity between the claustrum and these different networks is also drastically altered in ways that are much different than what happens under normal conditions. So things like extrinsic mode networks, like frontal parietal network, is also disrupted in addition to the default mode network. So a lot of things are happening when you're on psilocybin, and I think that the default mode network interpretation of its explanatory value of what it's doing, perhaps therapeutically, is captured a lot of attention because it's very intellectually engaging and has a lot of perhaps explanatory value to it.
Yeah. Yeah. And I guess when you think about it, it is sort of captivating in the sense that people are like, oh, default mode network, the sense of self. I lose my sense of self on psychedelics. It's sort of it feels nice that we might have an explanation there. But then if you stop and think about it, you're like, well, wait a minute. Psilocybin doesn't just change my sense of self, it changes everything. It changes the way I engage with the external world as well. And what you effectively just told us is it's not just affecting the default mode network, it's affecting probably every network we could look at under any number of circumstances. And it is kind of like, well, duh, of course it does. It's getting into the brain and it's going to affect every type of processing we have. Certainly, if you've ever experienced psilocybin, that's going to be a pretty unsurprising statement.
Yeah, absolutely. And, getting down to the pharmacology, the active ingredient of psilocybin, psilocin, doesn't just activate, 5-HT2A receptors.
Right.
And 5-HT2A receptors aren't just present within default mode network regions of the brain. So it's activating lots of different serotonin receptors, including 5-HT2A, which exists in other systems outside of the default mode network. So just looking at, psilocybin's effects through a 5-HT2A receptor lens, it has to be involving other networks and brain regions.
Right. And have you looked at the effect of psychedelics with respect to the claustrum specifically?
Yes. So in collaboration with Dave Semenowitz and Fred Baird at Hopkins, we imaged people in the scanner fMRI and challenged them with a relatively lower dose of psilocybin, 10 milligrams, and found that networks dissolved, but the functional connectivity of the claustrum with these different networks was drastically altered. And the integrity of these different networks themselves was altered in a way that related to the functional connectivity of claustrum to these different network regions in the cortex. And the other thing that came out of that study was if we look at the claustrum in particular, using that imaging approach, we saw a decrease in these so-called amplitude of low frequency fluctuations in the claustrum, suggesting that what psilocybin is doing is having this inhibition effect on the claustrum itself.
And aren't there some observations out? What are the observations out there generally in the literature from like the EEG and the fMRI literature on what psilocybin does to sort of global cortical brain activity? I've heard a lot of people say that in general, we sort of see a dampening or an inhibition of activity, that overall activity seems to go down in the cortex. Is that generally true? And does that kind of start to fit with what we know about the claustrum and how it works through inhibition?